Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems based on the concepts of vectors in R squared. So let's start with the first problem. So in part A, if AI plus 5J is equal to negative 3 comma B, determine the values of A and B. So in part A, we are given this vector a plus 5, which is in unit vector form, and we are given the other vector negative 3 comma b, which is in component form. So we have to find the values of a and b, and we are given that these two vectors are equal to each other. So the first thing we can do is to rewrite this vector in unit vector form in component form. So we can rewrite this equation as, so this is the given equation. Now two vectors are equal to each other if their x components and y components are equal to each other. So that means A should be equal to negative 3 and B should be equal to 5. So this should be the final answer for part A. Now we can analyze part B. In part B, calculate the magnitude of negative 3 comma B after finding B. So we know that the B value is 5, so we have to find the magnitude of vector negative 3 comma 5, and we can find the magnitude by squaring the two components and adding the squares and applying the square root to the sum. Now we can simplify this expression. So negative 3 square is 9, 5 square is 25, and 25 plus 9 is 34, and we can do square root of 34, which is equal to 5.83. So this is the final answer for the magnitude of vector negative 3 comma 5. So we are done with the first problem. Now we can analyze the second problem. If vector A is equal to negative 60 comma 11 and vector B is equal to negative 40 comma negative 9, calculate each of the following. So let's start with part A. So we have to calculate the magnitude of vector A and magnitude of vector B. So let's start with the magnitude of vector A. So we should square the x and y components of vector A, add the squares and apply square root to the sum. Now we can simplify this expression. So negative 60 square is 3600 and 11 square is 121. So this is equal to 3721, and the square root of that is 61. So that's the magnitude of vector A. Now we can find the magnitude of vector B. So for that we'll use vector b. So we'll square the components, add the squares and apply the square root. So negative 40 square is equal to 1600 and negative 9 square is 81. And square root of 1681 is equal to 41. So that's the magnitude of vector b. So we are done with part A. Now we can analyze part B. So in part B, we have to find the magnitude of A plus B and magnitude of A minus B. So let's start with A plus B. So the first step is to find the vector A plus B. So we'll add the two given vectors. So we can add the x components and y components of these two vectors. So negative 60 plus negative 40 is equal to negative 100. And 11 plus negative 9 is equal to 2. Now we can find the magnitude of A plus B. So we can square the components and then add the squares and apply the square root. So negative 100 square is 10,000. And the square root of 10,004 is 100.02. So I rounded the answer to 2 decimal places. So this should be the final answer for the magnitude of A plus B. Now we can find the magnitude of A minus B. So first we have to find the vector A minus B. So we should subtract the vectors. So we'll subtract the x components and then the y components. So negative 60 minus negative 40 is equivalent to negative 60 plus 40. So we'll get negative 20. And 11 minus negative 9 is equivalent to 11 plus 9, which is equal to positive 20. Now we can find the magnitude. So we'll square these two components and then add them and apply the square root. So negative 20 squared is equal to 400 and 20 squared is 400. And square root of 800 is equal to 28.28. So I rounded the answer to 2 decimal places. So this should be the final answer for the magnitude of A minus B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.